The diffusion of hormone thyroxine and triiodothyronine from thyroid during metamorphosis causes the metamorphic changes in the frog. Thyroxine, that is T4, and triiodothyronine T3, these two hormones are released from the thyroid during metamorphosis. Prolactin, as I have already told you, is like the juvenile hormone in insect. It is released from anterior pituitary. Prolactin acts as a larval growth hormone and inhibits metamorphosis. It is said to counteract the effects of thyroid hormone. Thyroid hormone initiates numerous morphological, biochemical changes in amphibian metamorphosis. At hormonal level, metamorphosis is characterized by interaction between two kinds of hormones, thyroid hormone and prolactin. जैसे कि मैंने आपको बताया कि फ्रॉग्स के अंदर या एम्फीबियंस के अंदर प्रोलैक्टिन हार्मोन होता है जो कि जुवेनाइल हार्मोन के इक्विवेलेंट होता है. जब प्रोलैक्टिन हार्मोन की कॉन्सेंट्रेशन ज़्यादा होती है तो थायराइड हार्मोन दैट इज़ T3 एंड T4 की कॉन्सेंट्रेशन कम होती है. और जैसे जैसे T3 T4 की कॉन्सेंट्रेशन बढ़ेगी वैसे वैसे प्रोलैक्टिन की कॉन्सेंट्रेशन कम होगी और मेटामॉर्फोसिस होगा. While the thyroid hormones such as T3 and T4 stimulate the metamorphic process, prolactin, which is secreted by the anterior pituitary, inhibits the changes. The concentration of these two hormones is what that controls the different stages of metamorphosis. During metamorphosis, most structures useful during the larval stages are regressed or reabsorbed through apoptosis. In many cases, this process is highly conditioned by various environmental factors like population density, food availability, presence of chemical substance in water. During the metamorphic changes or during the pre-metamorphic changes, the portion of the brain, that is the hypothalamus and the pituitary, is underdeveloped, and this results in the secretion of prolactin from the anterior pituitary, and there is no or very little thyroid stimulating hormone produced by pituitary. Thus, the level of T3 and T4 is low in the pre-metamorphic stage. The thyroid stimulating hormone releasing factor TSHRF causes the rise in the level of TSH. This TSH causes the thyroid to increase T3 and thyroxine synthesis. Thus, T3, that is triiodothyronine, is released from the thyroid and its concentration increases gradually until the anurin reaches the prometamorphic stage. During this time, the hind limb starts to enlarge. The rising of T3 level also stimulates the further development of hypothalamus hypophysis axis, which mediates the flow of TSHRF to reach anterior pituitary. There is then a positive feedback wherein increased T3 production causes more T3 production. In addition, the hypothalamus begins secreting a substance called dopamine that inhibits the pituitary synthesis of prolactin. Thus, the ratio of T3 to prolactin increases and the amphibians reaches the metamorphic climax, in which most of the development associated with metamorphosis takes place. One of the effects of metamorphosis is the partial degeneration of thyroid, and it is also possible that high level of T3 have an inhibitory effect on TSH releasing factor production. Thus, a new balance of hormone is acquired. Different organs of the body respond differently to hormonal stimulation. The same stimulus will cause certain tissue to degenerate while causes the other to develop and differentiate. For example, the tail degeneration is associated with increased level of thyroid hormone. This can be shown experimentally also. Moreover, prolactin inhibits the degeneration of tail, while the thyroid hormone causes the degeneration of tail. The response of thyroid hormone is intrinsic to organ itself and is not dependent on other factors. One of the